Hi, welcome to Revolutions. I'm Alex, and today I'm here with Semyon Brayman with ERS Engineering. And today we're going to be talking about through surface hardening. So, I know that through surface, could you start by giving a little bit of general background about what through surface hardening is and how it's different from other metallurgy processes?
This is a new technology, and basically it was designed to replace carburization. Today, most parts that required hardening process through the carburization. And this technology was developed some time ago in Eastern Europe, and we're bringing this technology here in North America. And the main purpose of that, to remove all the necessary or unnecessary stuff that touch to the carburization, like furnaces, like oil quenching, all different things that make it difficult, expensive, to replace it with a process that much better, much cleaner, and have better results.
Okay, so I know that kind of one of the big things about through surface hardening is that it's kind of designed to be a more affordable option compared to a lot of other metallurgy techniques. What kind of, I guess, motivated ERS to kind of develop your products in that direction?
The main thing with this process is a steel. They call it low hardenability steel. Utilizing this type of steel, we can have a very simple process. It's a heating, and heating can be done with induction or with furnaces, and then intensive quenching. And we received at the end of this process the part that have counter hardening with a much better quality or performance features of the part. Okay. Then, for instance, that two major advantages of quality is very fine grain size. Today, carburization required or can produce parts with no more than 6 to 8. If you got 8 grain size, it's very good. In our process, we can get 10 to 12, sometimes even 13. And the smaller grain size, the better part performance. Another thing, it's the compressive stresses, residual compressive stresses that make part much stronger, much more durable. In carburization process, it's no more than 300 MPa. We can achieve thousands, 3 times better.
Okay. So we kind of, I think, just touched on it a little bit, but aside from the affordability angle, what are kind of some of the other primary benefits of using this process?
Of course, this process is very important. It's make product much cheaper. To use this process, we don't need furnaces, and also that is key of this process, we use so-called low hardenability steel. This steel does not require expensive alloys material like other steels. It's why it's much cheaper, or can be no more expensive than any steel that's used for carburization processes. So it's cheaper. Number two, you don't need furnaces. You need only, let's say, induction equipment and a quenching equipment to perform the whole operation, and timing. Usually on carburization, you need maybe 8 to 20, average 12 hours to do the process. In this process, we can do it no more than 3 minutes per part.
Okay. So are there any, I guess, like industries or specific applications in particular that benefit from through surface hardening's properties?
This technology can be applied to any components that require case hardening, any component. And of course, you look in automotive industry, aerospace industry, people who produce all kind of off-highway equipment. Anywhere when required case hardening, this process can be used. And of course, it's a very big applications with the gears. Of course, most gears require case hardening, and of course, we can apply this process to produce these gears.
Okay. And then I guess, is there anything else that ERS is showing off at the show this year?
Very important thing that this low hardenability steel is not available in the United States. And what we did a few years ago, we have a chance and we produce on commercial basis first heat of the steel, and we proved to everybody that it can be used any mill with equipment, and it can be very cost effective. Now we have mills, it means the steel companies, ready to start to produce the steel. It's very important. So if we go to the potential customer, the steel will be supplied from United States, and also we have a very good partners with induction equipment and capability to do all kind of testing that we can start to work with anybody. And we have a third generation of steel available, and this generation of steel better than before because we can do much tighter tolerances on a ideal diameter. And this steel, it's feature of this steel is you can go for the 6 to 16 millimeters ideal diameter or critical diameter, and we can do plus minus 1 millimeters that we can perform, or provide very good steel for specific applications.
Okay. Before we go, is there anything else that you wanted to last minute touch on that we haven't covered yet?
Our biggest not problem, but obstacles so far was that, to implement this technology, the people who doing that, who require that, they have to replace their carburization, their furnaces. So it's very important timing. If somebody who has a new product or ready to replace their equipment, it will be very good for them to start to look an alternative to, it means on our technology, because it's a lot of savings and plus it's a lot of advantages as far as quality of the final component.
Okay. Thank you very much for all your time.
You're welcome.
As always, this is Revolutions. I'm Alex, and today I was talking with Semyon Brayman.